Hi. So the goal of this video is to go over exam number 2 for EML 3035, and we're going to go over the practice exam from a previous year. And note that this is actually kind of a combination of a few old exams just to kind of focus on things that we're specifically talking about currently in the class. You'll see that there are some multiple choice or free response. I got rid of the free response. Some multiple choice that are blacked out because we haven't covered that stuff yet, and it's not going to be tested on in this exam. Let's go ahead and start with the multiple choice and go from there. So for number 1, it says, what is created if you type 1:3:9 in MATLAB? Well, we know what our colon operator does. It's going to start with the number 1. That's what the first number means. And then we're going to increment by this much. So we'll add 3. That'll give us 4. We'll add 3. That'll give us 7. If we added 3 again, we will go over 9. Remember that this number here is the max possible number. So that means that our answer is going to be 147. This one doesn't make sense because it's incrementing initially by 2. This one doesn't make sense because we increment by 3, and then the last one's incremented by 2. This one doesn't make sense at all because it goes on for a while. I think that's just to give the idea that there's 9 numbers being used, which isn't correct. And same thing here, this is being incremented by 2. What type of variable is created with the line of code below? We see that there are double quotations. This is a string. This is something that you have to study and you have to understand. Single quotes are for characters. Double quotes are for strings. And if you see curly brackets with anything inside, that's going to be a cell. And then doubles are numbers. What does it mean to transpose a matrix? Well, when we transpose a matrix, conceptually, if I give you a matrix that looks like this is 1 row by 3 columns. Transposing it will turn it into 3 rows by 1 column. That's what the transpose is. So let's see if we can reason what the answer is based on that. We're not going to multiply it by itself. We're not going to make all the elements equal to 1. So switch the row and column index of each element. Okay, that sounds pretty good. To remove elements equal to 0, that has nothing to do with it. To solve a system of equations, that has nothing to do with it. It is strictly to do this. And what this means is that if I give you something like a matrix A, like this, and then we transposed it, if you look at, let's say, this one, this is A12, this becomes A21. We've switched the row and column index of all the elements. That's what ends up giving this change in the matrix from a row to a column. So even if it's not a 1 row or 1 column, this is still true. If you have 3 rows and 3 columns, you'll end up switching the row and the column indices for each of the elements in the transpose. What command allows multiple plots to be on the same figure? Again, this is something we should know by now. This is hold on. Plot on is not a thing. Plot off is not a thing. Hold off is when we would want 1 plot to remain. We'd overwrite our plots. And then figure overwrite's not a thing. Okay, moving on to number 7. Which of the following plots a vertical line? So let's go ahead and look first off at what MATLAB does. When we're plotting in MATLAB, this is our matrix of x variables or x values. And this is the matrix of y values. So if I were to give you a vertical line, something like this, and I were to just pick 2 points, the x values on that vertical line have to be the same. So this point might be something like 1, 2, and this might be, this might be 1, 4, or something like that. Oh, my dog is here. Hello, dog. That might be something like 1, 4. So the x values have to be the same, which means that C and E are out. D is out because that's just plotting 1 point. If you do 1, 1, that's literally just going to plot 1 point. You won't even see it unless you specify that you want a marker to be there. Now you're stuck between these two. You have 1, 1, 3, 3 and 1, 1, 3, 4. If you were to go ahead and think about these as x coordinates and y coordinates, this first one is plotting 1, 3 and 1, 3, which is plotting the same point twice. So really we would end up with just 1, 3, and then right on top of it we have another point. That is not a vertical line. Our answer therefore has to be B, because I can replace these here more in terms of the question. But if you were to come here and say that this is 1, 3 and 1, 4, that gives us a vertical line. So the x coordinates are the same, y coordinates are different. So what command can I write to create the following matrix? We have this matrix of 12s. So let's look at these one at a time. You have A is this matrix full of 12s, but does it match the size? So this matrix here is 2 rows by 3 columns. This one here, if you were to write this out, it'd be 12, 12. The semicolon means we go to the next line, 12, 12, and 12, 12. This is 3 rows by 2 columns. They are not the same. They're actually the transposes of each other. So A is out. Answer choice B is saying that you're going to use the ones command to make a 12 by 12 matrix of ones. So inside the ones command, which is our pre-allocation technique, the things that go inside of the command tell you the size of the matrix. So if I do ones of 12, 12, that means that I'm going to have a 12 by 12 matrix of a bunch of ones. You know, this is 12 rows and 12 columns. So B is out. This is saying that we're going to take 12 and we're going to add 2 rows and 3 columns of ones, which if you weren't sure what this did, if you were to do 12 plus a bunch of ones, that would give you 13. Or if you're like, why, I can't really add these together, they're different matrix sizes. Either way, that's not going to be the answer because it can't match the given matrix A. So that's out. A is equal to rand of 12. Well, rand is just going to create a bunch of random numbers that are not 12. The answer ends up being E in this problem. This says that we have a bunch of ones in a 2 by 3 matrix. That's what this does. And then we multiply it by 12. And when we multiply a matrix by a constant, that constant is just going to be distributed to all of them. And that will end up giving us our 2 by 3 matrix of 12s. What is the purpose of pre-allocation? We discussed this in class, the idea of if I wanted to buy a house for a family, is it smarter for me to buy a house with 1 room in it and hope to have a whole family in it, or buy a house with the correct amount of rooms ahead of time? If you buy it with the correct amount of rooms ahead of time, that will ultimately save you on cost later on. The whole purpose of pre-allocation is to save computation time and to save computation cost. Everything else here has nothing to do with pre-allocation. So in this problem, there's a typo. That should say 162. The answer ends up being D for this problem. Well, let's explain why it's D. It says that I'm going to be adding the first and the second matrices here. And we have to ask ourselves, do we have a matrix of strings or characters? What are we adding together? So if we look here, they are both matrices of characters. And if we have a row matrix of characters and we add them together, when we're dealing with characters, we have to remember that we're dealing with the ASCII values of those characters. So you're not given a calculator on the test, so you don't need to know what the values are. But if you just go column by column, you'll see that h plus y, that's the first one. That's this guy. Use my little laser. H plus y. And then you have I plus O, which happens to be 216. That's, again, we're adding element by element. If we're adding matrices, we'll add the corresponding elements together. H plus Y again is another 162, and I plus O is another 216. The answer ends up being D. If they were strings, then you might have something that's more so what you see here. And it depends on how you were to organize the strings. But because they are characters, what that is doing is adding the ASCII values, the numerical counterparts of the different letters. Okay. What color will the graph be if the command below is used? I tell you color is 0, 0, 1, and I tell you plot x, y. We have the property. We can tell because of the apostrophes there. And then we're using that variable color here. So this is 0, 0, 1. And the question is, what color is that? This is understanding that in MATLAB, they deal with RGB notation. And if red is 0 and green is 0, that means that red and green are not present at all in the color. The only color that is present is blue, which is why our answer ends up being B. What is the output of the code below? So I give you this matrix test, which has a bunch of things in it. And then I say, what is the class of test of 2, 1? So first off, test originally, what is the data type of this whole matrix? Well, the curly brackets tell us that this has to be a cell. And if you remember from class, I used this Rick and Morty reference with the whole parallel universe thing where data types do not exist. So anything that is inside of there, they all can go together. It's not a big deal. You see that the first one is a string. The second one is characters. That's a double. That's a string again. But inside of this cell, their data types are no longer present. Now, to get them back, the data types, we have to use curly brackets to bring them back. So if I were to do tests of, let's say, curly bracket 1, 1, that will give me this, which would be retain its original data type back, which is a string. If I were to do test of, let's say, 2, 1, well, if you look, this semicolon here makes this a 2 by 2 matrix. So if we're to do test of 2, 1, that would be 37, which is a double. So once you use the curly brackets, it brings back the data type. Now in this problem, I say, what is test of 2, 1? Well, test of 2, 1 is going to pull out the 37, but I didn't bring it back from the universe. It is still going to be a cell. Now, if we wanted to retain that data type, we'd have to use the curly brackets like I just said. But since I didn't, test of 2, 1 will just still be a cell no matter what. And reminder, that's what class does. Class tells us the data type. Assuming that I have data in the matrices X and Y, what line of code below should I type to plot the data on a red dashed line? So I don't know if we talked about this in as much detail this semester, but I'll just talk about it now. We can combine some of our properties into one entry. So in this case, if I were to do plot X, Y, R0, this means red circles. And that is not what this question is asking. That is out. This is saying plot X, Y. The color will end up being red. The line style we said is D. Well, I give you on the sheet what these are. We see that D is for markers. That's a diamond. Dash is a dash dash. So that answer can't be right because I'm saying line style D. Well, that's not even a choice under line style. So that is off. So that's out, that's out. The last one's just red. And then, or C is just red, and the last one is red and it's dashed. Again, we've been focusing more on the idea of actually writing the property name out. So I would do something like color, red. I can do line style. Dash dash. And that is equivalent to D. As you get better in MATLAB, you'll start to learn the shortcuts. And D is the shorthand notation of what I just wrote. What is the final value of sum in the code below? So we have a for loop. Let's go ahead and let's make a table keeping track of our variables. So say sum is 0, and then I also care about m. M will take on the values 1, 2, and 3 one at a time. So if we say that sum is equal to sum plus m squared, well, the first value of m is 1. So sum is equal to sum plus m squared. Sum is going to become 1. We then come back up. M is going to become 2. Sum is equal to sum plus m squared. Well, that's 1 plus 2 squared, which means that sum is going to become 5. We come back up again. Now we have that m is equal to 3. Sum will be sum plus 3 squared, which is 9. So 5 plus 9 is 14. And then we leave the code at that point since m is taken on each of these values one at a time. Therefore, our answer is 14. This one we did in class, but I'll do it again in case you missed class. Based on the structure created below, which line of code would output a 3? So I say people is equal to Brett, Samantha, and Robert. We see that inside that people matrix, they are all strings, which means that this is a 1/3 matrix of strings. I then say that data.Brett is 1. So really what that means is I have data. The name of my sublayer is Brett, and underneath that is a 1. I have Samantha. Underneath that is a 2. And then the last one says that Robert is a 3. And the question is, which line of code would equal 3? Well, let's go through the ones that look easiest first and try to eliminate them. Like, let's look at D, because D is pretty simple. We see data.Robert, and your first instinct might be, oh, that has to be 3, because that's literally what this is. But remember that MATLAB is case sensitive. So that means that this does not work. Data.Robert with a lowercase r does not exist. So that is out. If we do data.people, our instinct might be, oh, let me go to the matrix people and grab the third element. That's Robert. That's incorrect. Remember that MATLAB does not know what you're trying to do. If it sees data.people, it thinks you want to go to data and you want to find a subheading that's called people, which currently does not exist. So that's out. And the same thing is true for answer choice B. If you look at B, you have data.people of 1 plus data.people of 2, where again, it's expecting to find a subheading called people or a sublayer called people. That's a matrix that has an element, 4, 7, 6 or something. This is saying data.people of 1 would be 4, data.people of 2 would be 7. You add them together, you get 11. But again, in this problem, this does not exist. So that means that that is out. And now we're torn between A and B, and this is a matter of reading the question carefully. If you look at A, you have data.people of 1. So here's our parenthesis for our dynamic structure. And the closed parenthesis for this, I'll try to use different colors here to show this. That's a parenthesis. That means that the black one is all the way over here. That's going to give us an error because it's trying to do a lot of things at once here. And it's not going to work. What we do want, though, is answer choice C, because data.people of 1, this is saying go to the matrix people, grab the first element in it. Again, that's what these outer parentheses do. That's the whole point of dynamic structures. These outer parentheses here are what allow us to do this type of manipulation. It's going to be data dot. We're going to go to the people matrix and grab the first element. That's going to be data dot Brett. And we're going to add that to data dot people of 2, which is data dot Samantha. And we know that data dot Brett is 1. We know that data dot Samantha is 2. So that ends up equaling 3, which is why this is our answer. Tricky. As we get into structure get a little bit confusing. Which graph corresponds with the code below? Note that all graphs are the same color and line width. Answer choices are below the graphs. So I give you these 4 graphs, A, B, C, and D. And we want to guess which graph is representing what. So we have X goes from 0 to 0.01. Oops. To 2. And then we're going to square it. And remember, that dot is squaring all those elements. So Y is going to ultimately go from possibly 0 to 4 if we were to graph it. Or rather, this would be something like 0, 4, and this is 0, 2. Let's just keep that in mind. Let's keep looking. It says plot X, Y, and it says colors and lines don't matter, so we're just going to ignore that. But we're plotting X versus Y. And now here's where the differentiation comes in. The first thing is that we have Y label. Y label is time. So that means we have to look at the Y-axis and make sure that the Y label is time. So that means that A and B are out because their Y labels are distance. If you look at the X label, those are distance. Okay, so that doesn't help us differentiate. But now what we have to do is look at the limits here. So we see X lim goes from 0 to 4, which means that on the X-axis, the limits of the X-axis must go from 0 to 4. And just based on that information, we know that our answer choice has to be D. The Y-axis goes from 0 to 2, which we see is what is happening there. And the grid is on. The grid is on for all of them, so it doesn't matter. The answer has to be D. And if you look, the X graph, and this is kind of the whole point of the problem, is to see if you were paying attention to the Y lim and the X lim. If you look at X, X goes from 0 to 2 is what we're plotting. So we see that this does go to 0 to 2, but we have cut off the remainder of the Y graph. This graph still keeps going, but by making the Y lim go from 0 to 2, we have basically zoomed in on that graph. So that's why D is our answer in this case, just by looking at the X label, Y label, and the X lim and the Y lim. What is the output of the code below? Now, this is the question I think that screws people up the most. This is a hard question, and a lot of people think it's easy because they are not understanding entirely what the for loop is doing. So, II is equal to 1. We have a few other variables here, so let's make a table. II, KK, and then diff. So we have 4KK is equal to 1313. Is KK equal to that entire matrix? Like if I were to type KK into the command window, would 1313 pop up? And the answer is no. For for loops, the variable takes on one value at a time. So in this case, when we come in, it says kk is equal to 1. That's how it starts. It says that diff of 1 is going to be kk minus kk of 1. Well, kk is 1. And what's the first element in kk? Well, kk is only this. That's all it is. So the first element is 1. That makes it 0. Okay. I goes up by 1 based on this line. We come back up. Kk becomes 3. Difference of I is going to be kk minus kk of 1. Kk of 1, we have to look at what kk is. It's just this. Kk is a single number. It is not a matrix. This question always trips people up. Remember that kk is not equal to 1313. It's only equal to whatever its current value is. So kk during this iteration is equal to 3. If I do kk of 1, that's saying go to this matrix, which is just the number 3, give me the first element. Well, that ends up being just 3. And you can continue this problem, and you'll see that the only answer choice that works is A, because every time we have kk, we're just going to be subtracting itself. 1 minus 1, 3 minus 3, 1 minus 1, 3 minus 3. That is a really important point in that kk is not this whole matrix. It's just one of those numbers one at a time. What is the value of z in the code below? So this is just testing our abilities of understanding linspace and the colon operator. Let's look at x first. X says start at 0 and go up in increments of 3 until you get to 4. So you go 0, we go up by increments of 3. If we went up by 3 again, it would give us 6, which is over our limit. So that is x. And linspace is saying to start at 0. Remember the notation here. This is the start. That's the end. And this is the number of points. So we're going to start at 0, end at 3, and we have 4 total points, which means we need 2 more numbers on our list. Hopefully it's obvious to see that the 2 numbers we pick are the ones that make everything evenly spaced. So in this case, y will just end up being 0, 1, 2, 3. They're all separated by 1, and there are 4 numbers in the list. Z is going to be equal to x of 2, which is 3, plus y of 2, which is 1, which means that our answer is going to be 4. Question 20. What is the variable answer in the code below? So here is just a way to try to confuse you. This is just meant to be, are you keeping track of what is what? So I'm just going to comment out and try to write down what is happening here. I have this variable, or this matrix called character, which is what data type? Well, based on the curly brackets, this is going to be a cell. That's the data type right now. In the next line, I'm going to go to that matrix character and take out the element that's in 2, 1, which is single. If you were to write the cell out, we would see that it just ends up being, I'll do it in big curly brackets, double, single, triple. The semicolons are why we have multiple rows. So this is then go to the second row in the first column, which is this guy. And I want you to bring it back to our world, because we're using curly brackets, which means now that what we have is we bring back the data type associated with the word single, which is a string. This is a string at this point. The next line says to take the char of that variable. You see here cell, we're going to take the char of cell. That means we're going to convert our single word, which is a string, into a character. So now we have single quotation marks. This is a character. And our answer is to take the second letter in that character, which happens to be I. And that is our answer. So we see this was the string, that was the single, and I go to that variable, which I just arbitrarily called string just to confuse people, and I ask you to tell me the second letter. Okay. Last 5 questions. What should I assign the variables matrix 1 and matrix 2 to in the code below so that the code does not produce an error? So if you look at the code, we assign a matrix A, assign a matrix B. We want to do something with those matrices in order to run the last line of code. This product is equal to matrix 1 times matrix 2. So this is understanding when matrix multiplication is allowed or when it's not allowed. Let's go to matrix A, which is what size? This is 465 is what it says. That looks like it's 1 row by 3 columns. And matrix B, again, it's 1, 6, 7, semicolon, 4, 2, 2. This is 2 rows by 3 columns. And we want to know, what should we do to matrix A and B in order to make this multiplication possible? So let's look. This first guy says that we can just leave A and B as is, because it says matrix 1 is A multiplied by matrix 2 is B. Can we do that? So let's write down for A of 1 by 3, B at 2 by 3. We cannot do that because the inner indices do not match. That is out. Okay, let's look at B. This says to take the transpose of A, that's going to be matrix 1, and multiply it by B. Well, the transpose of A will be 3 by 1, and B is still 2 by 3. That also doesn't work if the inner indices do not match. Okay, C says we're going to take A and multiply by B transpose. So A is 1 by 3, and B transpose will be 3 by 2. That is possible. That will not give us an error. This will end up being our answer. Let's go ahead and double check with D. And the reason it is because the inner indices match, of course. The last one says to take the transpose of both of them and multiply them together. So it says A transpose is 3 by 1, B transpose is 3 by 2. That does not work. The answer has to be C. Now, of course, if C didn't work, then the answer would be E. But in this situation, we see that the multiplication would work, where the product of A and B prime would end up giving us a matrix that's ultimately 1 by 2 because of the fact that outer indices become the dimensions of the new matrix. What is the output of the code below? So it looks like that there are a few variables here. If we're just skimming, we have X, Y, and I. So let's go ahead and make a table with X, Y, and I. It says that X is 2, Y is 1. For I is equal to 1 to 3. So remember that this is going to take on the values 1, 2, and 3, one at a time. So the first value of I is 1. Okay. So now we come into our for loop. It says that X is equal to X minus I. So x is going to become 1. And again, we're right here. We just said x minus I, that's 2 minus 1 is 1. Now we have a while loop. And this whole while loop has to finish or go on forever or something in order for us to come back to the for loop. It's the same idea as a nested for loop, where the thing on the inside has to finish in its entirety before we restart. So this says here, while x is less than 5, which it currently is, it says that x is equal to 2 times x, so that means that x is going to become 2. Y is equal to y plus 1, so that means that y is going to become 2. We come back up. Is 2 less than 5? Yep. X is equal to 2 times 2. That means this will become 4. Y is equal to y plus 1. Y is going to become 3. We come back up. Well, x is less than 5. It still is less than 5. We will now double x again. X becomes 8. Y becomes 4. And now we come back up. That while loop no longer works. So what we're going to do is end and come back here, and now come back to the top where I becomes 2. X is going to be x minus I. So x is x minus I, which will become 8 minus 2 is 6. That while loop will not start. So we skip it. We come back up. I becomes 3. Now we'll say that x is equal to x minus I. So x now will become 3. The while loop is satisfied again. So now we're in here again. X will be 2 times 3. X is 6. Y goes up to 5. X is no longer less than 5, so we then ended the while loop. Are we done with the for loop? Yeah, we're done with the for loop. We've gone through all 3, and the question says, what is the final value of y? That is 5. I hope that makes sense. Follow the logic slowly. If you need to rewind, it's not a big deal to rewind or rewatch or slow it down. But again, we're just going step by step, filling out this table as we move. What is the value of letters when the code below completes? So we have dictionary, which is a cell with a character inside, but we don't know that. It's hidden. Then we have dictionary of 1, 1 with curly brackets. So that means we're going to extract the word support. So this thing here will be support as a character. And then this notation here is saying inside of the word support, I want these specific elements in that order. So if I have 7, -2, 0, this says start at 7. Let's move this over here. Oops. This says start at 7 and go down in increments of -2 until you hit 0. So it's going to be 7, 5, 3, 1. And if you do another -2, then you'll go to -1, which overcomes 0. So that doesn't work. So this is saying in the word support, go to the 7th element, SUPPORT. That's the 7th element. It's the 5th element, the 3rd element, the 1st element, and it's going to be presented in that order because we asked for the 7th letter first. So that means that our answer will end up being TUPS. It would be an error if we had parentheses here and not curly brackets. With the curly brackets, that again extracts it out so that we can bring back its data type, which is a character, and now we can mess around with the character and extract specific letters or things along those lines. All right, last problem for the multiple choice. There are a few extra credits that we won't get to because they're on things that we're not covering yet. Let's go ahead and look at this one. This was probably the hardest problem on the test, number 25. So it says, what is the value of x at the end of the code? And I give you this array pets. and I have age, which starts at 2. And I go through for I is equal to 1 to length of pets, and then I start doing something with dynamic structures. We see here that we're going to be accessing things in the pets matrix and setting it equal to the age. So the hard part of this problem, there's 2 parts. The first part is recognizing what is the length of pets. Is it 4? Because it's 4 animals. It's not 4. It is bigger than 4 because of the fact that we have characters. So if you look, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This length of pets is 14. And your first thought might be, oh my God, I have to run this for loop 14 times. You don't, because you have to look ahead at what the problem is asking and then think about it, how many times you have to go. Let's take a look. So we're going to create a structure animals. I'll do a variable I that starts at 1. It says animals.pets of 1. In the dynamic structure, that's going to be animals dot what? Well, this is saying go to the first entry in the pets matrix, which is a D, and assign that sublayer, animals D, that will be assigned to the age of 2. So that means that at that point, we're going to go up in age by 2. Now, we could do this 14 times. Let's just look ahead. X is going to be equal to animals.pets of 2, which is going to be animals.o, and animals.pets of 4, which is animals.g. So those are the things that we have to find. Let me make sure that this is clear. That's not a D, that is an O. O. So if we were to go and up in the for loop now, we just added 2 to our age. We'll now have I is equal to 2. So we're going to look at animals.pets of 2. This is an O. And we're going to say that that's equal to 4. That's the age. And then we'll add 2 more to the age. When you come back up, I is going to go to 3. Animals.pets of 3, that's going to be a G. And that's going to be assigned to the current age, which is 6. And then the age goes up again to 8. Now, this is where this problem gets tricky. I goes up to 4, and I want to know what is animals.pets of 4. Well, that's animals.g. Is there going to be another G? Does animals even know that this pets matrix exists? Because right now, animals, all it has underneath it is a D, an O, and a G. And now I'm saying animals.g again is equal to a new age. Do I create another G level? No. We replace this with an 8. Okay, so that means that the G is now an 8. And that's fine. Let's go ahead and increase age by 2 again. We come back up, I goes to 5. Now it says for I is equal to 1 to, or sorry, I is now 5. What's animal.pets of 5? That is an O. And that's going to end up being equal to 10. And if you look, there's no more O's and G's in the rest of the animals. It's just A's and T's and S's and whatever for cat and fish. We're done with O's and G's. And our answer is going to be animals.o plus animals.g, which is going to be 18. Remember, a thought might be, oh, well, animals.2, it's this O. It's this O. Let me highlight it. Or animals.g, it might be animals.for might be that g. It doesn't matter. What matters is what the current value in that layer of the structure is. If I do animals.o and set it equal to 1, and then later on I change it and say animals.o is now equal to 7. Animals.o is whatever the current value is. It's now 7. It doesn't matter if there was an O from a random spot previously. We're just replacing the name, which is why this problem is so hard, recognizing that we are overwriting the O and the G in our animal structure. So that's it for the multiple choice. I'll probably upload a different video for the free response for this exam, but I hope that this was helpful. If you have questions, please reach out to me. Okay, thanks. Bye.